Hello students, welcome to EPG Pathshala. I am Dr. Savita from Maharaja Agrasen University, Baddi, Himachal Pradesh. Today we are going to talk on module Theory of Production Part 2 under the paper Managerial Economics. After completing this module, you will be able to understand the isoquant and its properties, production function, isoquants line, conditions of producer's equilibrium, law of returns to scale, economies and diseconomies of scale, and elasticity of technical substitution. In the previous unit, we have completed our analysis of the short-run production function in which one input, that is labor, is the variable factor and the other input, land, is the fixed factor. The fixed factor could be taken as capital E1. Now we turn to the long-run analysis where labor and capital both are variable inputs. The firm produces its output in variety of ways by combining different amounts of labor and capital. These various combinations of inputs signify various techniques of production. Isoquants. This section deals with various combinations of labor and capital available with a production firm which generate same amount or level of output. An isoquant is the curve on which every possible combination of two factors, say labor and capital, gives the same level of output per unit of time. Table 1 shows a hypothetical isoquant schedule of a firm. It tabulates various combinations of two inputs, that is labor and capital, producing same level of output, that is 100 quintals. It shows different combinations of labor and capital, that is A 5 labor plus 9 units of capital, B 10 labors plus 6,000 units of capital, C 15 labor plus 4,000 unit of capital, and D 20 labor plus 3,000 unit of capital, each one producing 100 quintals of output. The information given in table 1 has been presented diagrammatically in figure 1, wherein labor units are measured along the x-axis while capital units along the y-axis. The point A represents the combination of 5 units of labor and 9 units of capital to give an output of 100 quintals. Similarly, point B presents 10 units of labor and 6 units of capital to get an output of 100 quintals. Likewise, point C and D show different combinations from the table. If we join points A, B, C, D, we get a curve known as isoquant or isoproduct curve Q, which is convex to origin. Diminishing marginal returns to variable factor. Even though both labor and capital are variable in the long run, it is useful to note that diminishing marginal returns to labor occur both in long and short run, because adding one factor while holding another constant eventually leads to lesser and lesser increase in output. diminishing marginal rate of technical substitution. In general terms, marginal rate of technical substitution of labor for capital may be defined as the amount of capital which can be replaced by 1 unit of labor, the level of output remaining the same. Shapes of isoquants. Linear isoquants assumes perfect substitutability of factors of production. A given commodity may be produced by using only capital or only labor or by infinite combination of K and L as it is shown in figure 2. Input-output isoquant. This isoquant sticked complementarily, that is zero substitutability of the factors of production. There is only one method of production for any one commodity. The isoquant takes the shape of a right-angled, figure number 3. This type of isoquant is also called Leontief isoquant, after the name of economics, Leontief, who invented the input-output analysis. Different capital-labor ratios are depicted by every isoquant. Isoquant X is possible with labor capital ratio OL upon OK, while isoquant is possible only with labor capital ratio OL1/OK1. Kinged isoquants. In case of kinged isoquants, there is limited substitutability of K and L. There are only a few processes for producing any one commodity, and the substitutability of the factor is possible only at the king, as it is shown in figure 4. This form is also called activity analysis. Smooth convex isoquant. This form assumes continuous substitutability of K and L only over a certain range, beyond which factors cannot be substituted for each other. The isoquant appears as a smooth curve convex to the origin as it is shown in figure 5. It should be noted that the kinged isoquant are more realistic. Engineers, managers, and production executives consider the production processes as discrete rather than in a continuous array. Two special cases of isoquants. Here we discuss two extreme cases of input substitution. When inputs used in production are perfect substitutes for one another, the MRTS is constant at all points on an isoquant. In simple words, the rate at which capital and labor can be substituted for each other remain the same matter whatsoever level of output being produced. Two special cases of isoquant curves. In case of two factors being perfect substitutes, the shape of the isoquant is shown in figure 6. Points A, B and C represents three different capital labor combinations that generates the same output. In this case, isoquant will be a straight line falling from left to right. The opposition extreme is the fixed proportion production function where it is impossible to make any substitution among inputs. Each level of output requires a specific combination of labor and capital. Additional input cannot be obtained unless more labor and capital are added in specific proportion. As a result, the isoquants are L-shaped, as indifference goods are L-shaped for the perfect complementary goods. In such a case, only one combination of labor and capital can be used to produce a given level of output, as at point A on isoquant Q1, at point B on isoquant Q2 and point C on isoquant Q3. It is shown in figure number 7. Adding more labor alone here in case of fixed proportion production function would not increase output, nor would adding more capital alone increase output. In figure number 7, points A, B and C represents technically efficient combinations of inputs for outputs level Q1, Q2 and Q3 respectively. For example, to produce Q1, input combinations of OL1 and OK1 is needed. Keeping capital at OK1 and increasing labor quantities wouldn't increase output. Parallelly, keeping labor fixed at OL1 and increasing the quantity of capital would not change output level. Therefore, MPK would be 0 along the vertical and horizontal segments of the L-shaped isoquants. Either the marginal product of capital or the marginal product of labor is 0. Higher output level is achieved only when both labor and capital are available in exactly same or fixed proportion. Thus, the fixed proportions production function describes certain situations in which method of production are limited. Properties of an isoquant. The concept of an isoquant, similar to indifference curve in consumer analysis. The properties of an isoquant are the same as that of indifference curve. Following are the important properties of isoquants. An isoquant slopes downward from left to right, or it has a negative slope. This is so because when the quantity of one input is increased, units of another input must be reduced so as to keep the quantity of the total output constant along an isoquant. Isoquants may or may not be parallel. Two isoquants cannot intersect each other. If they intersect, as it is shown in table 9, it will mean that at the intersection point E, a given combination of two inputs will give two different level of outputs, that is Q1 and Q2. But this is quite absurd. How can the same output combination produce two different level of output? Techniques of production remaining unchanged. As shown in figure 9, the labor capital combination OL and OK can provide either Q1 or Q2 level of output, which is not possible by defining of an isoquant. An isoquant is convex to the origin. The convexity to the origin of an isoquant to the origin is due to the diminishing marginal rate of technical substitution. The convexity of an isoquant also implies the operation of the law of diminishing marginal returns. The diminishing marginal rate of technical substitution occurs because of the fact that different factors are imperfect substitutes of each other in the production of a commodity. Higher the isoquant, higher the level of output. It is because a higher isoquant will involve larger quantity of at least one of the inputs, that is either labor same and more capital units, or capital same and more of labor, or more of both the inputs. In order to produce more output, this we can see from figure 8, where output levels Q1 and Q2, Q1 higher than Q, represent these cases. On the isoquant Q, the E point shows the labor capital combination as OL and OK, using OL and OK labor and capital produces Q level of output. Considering higher isoquant Q1, point B on it shows same amount of capital but more of labor. Hence, more will be produced. Point A on it shows same amount of labor but more of capital, hence more will be produced. And point C on it shows more of capital and more of capital both. Therefore, more of output will be produced. Hence, higher isoquants involves higher quantity of inputs resulting into higher level of output. Now, we will discuss producer's equilibrium. A producer hires services of various factors of production, combines them at the best possible technique of production, uses the required quantity of raw materials given the prices and given the budget in such a way that minimizes his cost of production and gives him the maximum possible output. When producer is in equilibrium, he is satisfied and doesn't want to change any arrangement. Technically, he makes use of two concepts, isocost line and isoquant map. Every firm wants to maximize its profits, so it chooses least cost combinations of factors. The least cost combination refers to a firm producing maximum possible output from a given cost outlay owner factors. The least cost or optimum combination is found out by combining the isocosts and isoquants. Isocost line. An isocost line is that line which shows the various combinations of factors that will result in the same level of total cost. It is locus of different combinations of two factors that a firm can employ but incur same cost to the firm. Just as there are various isoquants curves, there are various isocost lines corresponding to different factor combinations pertaining to different level of cost. In figure 14, labor is represented on OX axis and capital on OY axis. The point A, B, C and D shows the different combinations of two factors, capital and labor, which can be purchased by spending rupees 100. Point A indicates 5 units of capital and no unit of labor, while point D represents 10 units of labor and no capital. Point B indicates 4 units of capital and 2 units of labor. Likewise, point C represents 4 units of labor and 3 units of capital. All the combination, that is A, B, C and D, represent same cost of rupees 100. Hence, joining them, we get isocost line, that is AD. The situation of producer's equilibrium or optimum combinations of factors can be explained with the help of figure 11. Suppose a producer wants to purchase pen with a total expenditure of rupees 1500. He requires two factors, that is labor and capital, to produce this output. The price of labor is rupees 50 per unit and that of capital is rupees 75 per unit. He can either hire 30 units of labor and no capital or 20 units of capital and no labor. He will like to have optimum combination of both the factors. The optimum combination is indicated by point E using 10 units of capital and 15 units of labor. At point E, isoquant IQ is tangent to isoquant line AB. Theoretically, producer has the option of moving upward or downward from point E along the isoquant IQ or isocost line AB, but impractical. If he moves to point M or N on isoquant IQ, he would find himself on a higher isocost line, that is CD, paying out more and exceeding his fixed level of expenditure for the same output, that is for 100 pens. In other words, the cost of producing pens is minimum, that is rupees 1500 at point E. The point E will represent least cost combination. Expansion path. With an increase in the financial resources of the firm, while there is no increase in the cost of the factor, the level of total output of a firm increases. The optimum combination of factors used by the firm at different levels of output. Hence, cost is indicated by expansion path, since expansion of the firm is based on the scale of operation. Expansion path is also called scale line. Expansion path is that line which reflects least cost method of producing different levels of output when factor prices remain constant. Expansion path can be explained with the help of figure number 12. On OX axis, units of labor and on OY axis, units of capital are shown. The initial isocost line of the firm is AB, which is tangent to IQ at point E. the initial equilibrium of the firm, supposing the cost per unit of labor and capital remains unchanged, but the financial resources with the firm increases. Consequently, firm isocoastline shifted to the right as CD as it is able to deploy more inputs. The new isocoastline CD will be parallel to the initial isocoastline AB and touches higher isoquant IQ1 at point E1, which is the new equilibrium point. If the financial resources of the firm increase further, cost of factors remaining unchanged, the new isocoastline will be GH. It will be a tangent to isoquant curve IQ2 at point E2, which will be the new and higher equilibrium point of the firm. By joining together equilibrium points E, E1 and E2 of the producer firm, we get a line called scale line or expansion path. Ridgelines, the locus of points of isoquants where the marginal product of the factor are 0 from the ridgelines. Having taken units of labor on x-axis and units of labor on y-axis, the upper ridge line implies that the MP of capital is 0 and the lower ridge line implies that the MP of labor is 0. The ridge line is the locus of points on various isoquants where marginal product of input, capital or labor is 0, as it is shown in figure 13. Along the ridge line OL, the points A, B and C lies on different isoquants Q1, Q2 and Q3 but represent MPL is equal to 0. Along the ridge line OK, the points A dash, B dash and C dash lies on different isoquants Q1, Q2 and Q3 but all represent MPK is equal to 0. As shown in figure 12, after point A, if capital is kept constant at OK, introduction of more units of labor would result in fall in production as lower isoquant will pass through these points. So, in order to maintain the production level at Q1, it would be essential to introduce more units of capital along with more units of labor. Along upper ridge line, marginal product of capital MPK is 0 as it is shown in figure 13 along the ridge line OL. Returns to scale. In this section, we have discussed what happens when a firm substitutes one input for another in the production process. However, in the long run, when all the inputs are variable, the firm must also consider the best way to increase output by changing the scale of output. The change in the scale of operation means increasing all the inputs to production in a given proportion. When all the inputs are doubled, output will certainly increase, but it may double. It may more than double or it may less than double. Accordingly, they are classified as constant, increasing or decreasing returns to scale. Returns to scale. First of all, constant returns to scale. Constant returns to scale means that if all factors of production are increased given proportion, the output produced would increase in exactly the same proportion. Thus, if the quantities of labor and capital used per unit of time are both increased by 100%, output increases by 100% now. If labor and capital are doubled, output doubled. It makes sense. If we use two workers of the same type and two identical machines, we normally expect twice as much output as with one worker with one machine. Similarly, if all inputs are reduced by a given proportion, output is reduced by the same proportion. Figure 15 shows constant returns to scale. It shows that when we double both inputs, we double output. If we triple all inputs, we triple the level of output. Thus, OS is equal to ST minus TZ, and similarly for any other ray from the origin. Increased return to scale. Increased return to scale refers to the case when all factors are increased in a given proportion. Output increases in a greater proportion. Thus, if labor and capital are increased by 100%, output rises by more than 100%. If labor and capital are doubled, output more than doubles. Increasing return to scale may occur because by increasing the scale of operation, greater division of labor, if possible, and on account of that specialization becomes possible. Increasing returns to scale. The case of increasing returns to scale is shown here as an increase in both inputs in a given proportion causes a more than proportionate increase in output. Thus, OM is greater than MN is greater than NR. Once again, if relative factor prices remain unchanged, output expands along ray OD. Decreasing returns to scale. If output decreases in a smaller proportion than the increase in all inputs, there are decreasing returns to scale. This may result because as the scale of operation increases to quite a great extent, communication and managerial difficulties may make it more and more difficult for the entrepreneur to run a business effectively. In case of decreasing returns of scale, as it's shown in figure number 17, where an increase in both inputs in given proportion at increase in output. Thus, OG is less than GH is less than HG. It is generally believed that at very small scale of operations, the firm faces increasing returns to scale. Figure 17 shows decreasing returns to scale. Here, to double output per unit of time, the firms must more than double the quantity of both inputs used per unit of time. the returns to scale do not continue to be same throughout the production process. Returns to scale differ for different level of output. Economies and diseconomies of scale. It is important to find out the reason for the existence of increasing returns to scale, and also why does eventually diminishing returns to scale set in. The existence of economies of scale are said to be responsible for the emergence of increasing returns to scale. But the economies of scale cannot continue indefinitely, and accordingly, the diminishing returns to scale are attributed to the diseconomies of scale. Economies of scale internal. Economies of scale are the advantage which a producing unit enjoy by expanding the size of plant and the scale of operation. These advantages or economies enable a firm to get proportionately larger output than increments in factor inputs, or after adjusting all inputs, some of the economies of large scale are given as follow. Higher degree of specialization and division of labor. As scale of production expands, higher degree of specialization of both machinery and labor becomes possible. The use of specialized machinery and labor increases productivity per unit of input. Their cumulative effects contribute to increasing returns to scale. As scale of production increases, more labor is employed and the opportunities for specialization and division of labor are captured by the producing units. Technical indivisibilities. Some factors, particularly mechanical equipment used in the process of production, are available in a particular size, which cannot be cut down as per requirement of the firm. Full use of machines can be made only when production is carried on a larger scale, but because of indivisibility, they have to be employed even at a smaller level of output. Such inputs cannot be divided into small sizes to suit the small scale of production. Thus, because of indivisibility of such factors, they have to be employed in a minimum quantity even if scale of production is relatively small. Next one is managerial economies. Managerial skills are also indivisible, like specialized machines. Suppose a manager can optimally supervise 1 lakh units of production in a month, but only 80,000 units are produced in a month. Then the managerial cost gets distributed over less units of output. It will be possible to reduce cost per unit until 1 lakh units are produced, or total output will rise proportionately more with increment of labor and capital inputs. Superior machinery. The increase in the scale of production enables the efficiency of factors to be increased by the introduction of superior and more specialized machinery. So even if there is no lumpiness of a factor and all factors are proportionately increased, increasing returns may operate because of the possibility of introducing more superior and specialized machinery. Dimension relations. Increasing returns to scale is also related with dimensional relations. For example, when the size of a room is 10 by 10 is doubled, 20 by 20, the area of the room is more than doubled. Similarly, if we double the number of bricks and other inputs which are used, along with them, the storage capacity of the warehouse is more than doubled, or a case of increasing return, or a case of increasing returns to scale. Diseconomies of scale. Diseconomies of scale are the disadvantages which a producing unit gets by expanding the size of the plant or scale of production beyond a particular level. Some of the diseconomies of scale are mentioned as follows. Limitations to efficient management. Managing a unit entails controlling and coordinating a wide variety of activities such as production, sales, advertisement, transportation, etc. As the scale of plant expands beyond a particular point, top management is forced to delegate responsibility and authority to lower management. This leads to loosening of control and the efficiency of operation begins to decline, even if all the variable factors are increased in a given proportion. Total output in such cases doesn't increase by the same proportion. Limited use of the natural resources. If production involves use of natural resources, that is mining of natural resources, then this factor is very important. For example, doubling of coal mining plants may not double the coal output because of limited availability of coal deposits. It is quite difficult to determine when diseconomies of scale set in and when they become strong enough to overweight the economies of scale, but it is noticed that diseconomies become important when economies of scale are negligible. Elasticity of technical substitution. The elasticity of technical substitution is defined as the change in capital labor ratio divided by the percentage change in the rate of technical substitution. Elasticity of substitution is equal to percentage change in K by L whole divided by percentage change in MRTS of labor and capital. So students, let's now summarize what we have learned in this module. The production function expresses the relationship through which various inputs are transformed into final outputs. A production function with the two variable inputs can be represented by a group of isoproduct curves or commonly known as isoquants. Isoquants is like that of consumer's indifference curve. In long period, when all the factors of production used in the production process of a firm are changeable, it is known as returns to scale. economies of large-scale production have been classified by Marshall into internal economies and external economies. Thank you.